Thank you very much, Mr. Srikanth. I hope you can hear me.
Yeah, we can hear you. Please go ahead.
And I want to thank Indian Railways and the Institute of Railway Signal and Telecom Engineers, Chennai chapter, for giving us this opportunity to talk about how you can leverage technology. And just to give, I've been listening from morning and there's on the uh, edge cloud compute. And then there have been discussions about how we can use AI, ML, okay, or artificial intelligence and machine learning algorithms for processing data efficiently. And then we also heard about use cases, what are the different kind of approaches which are there. Okay. So now in this discussion, I'm going to talk about how you do the connectivity part, okay, in a secure manner, because that's what is going to become the critical part, so that from a railways perspective, we are able to scale and we are able to use this technology effectively for the the large deployments that we will end up having in the country. Okay, so we are not at this point talking about what happens in a particular station. Be for a division or a region, okay, is going to become the purview, which means you need to have a quick way of scaling this whole infrastructure and then also deploying it either in stations or on the track, or okay, it could be within the train itself. Because when I look at this hot axle problem that we were discussing, what's coming to mind is it requires coordination amongst different sensors. Okay. So quickly, I'm going to touch base on what are the trends which are there, okay, which are leading to automation. And with the current pandemic, that's actually accelerating many of these. Okay, and then what work we are doing from Hewlett Packard Enterprise and Aruba perspective on the intelligence from the edge. And from a railways to data sources, okay, then IoT projects have been a challenge for many organizations. So I'm going to capture some of that and then see how we can solve these challenges. Okay, so when you look at the challenges that we are seeing, okay, there's a lot of emphasis on automation. And this automation also requires us to rethink, okay, how we can quickly deploy the infrastructure and not spend too much of time. Can I use technologies like zero touch provisioning, wherein I put an element, okay, or an equipment, okay, either a network element, compute server, and then it's configured automatically from a centralized location. Okay, so these are the trends we are seeing, and then we need to support all of we are working, okay, from the Urba perspective. And when we look at the insight that we can deliver from the edge perspective, okay, this is a lot. And what happens is you have a lot of sources of data, which is some of that is going to become domain specific. Okay, for example, if I'm walking into a stadium, I'm going to have different types of data that's there. When I go to healthcare, okay, all my equipment that's there in the healthcare organization becomes the sources for data. And then when I look at it from railways perspective, you may have sensors, okay, the collection from signaling perspective, that's going to be a good collection as well. So in each of these of data that's going to be there, and then the data itself, we need to look at where it needs to be processed. Should it get processed at the edge itself? Or do I need to take it into a hybrid cloud or a cloud? Okay, or it's possible that I need to take it everywhere, okay, so that there's enough visibility to what's going on. And some of the statistics that we have seen from the industry perspective is IDC predicts that there are going to be about 55 billion devices coming onto the edge by 2022. And if from the projects that I've seen taking off so far and then being successful, I think we may end up beating these numbers, and it's going to be beyond that. And then the next prediction that's there is 75% of data that's going to be required or generated is going to be outside the data center or cloud. Again, if you look at the volumes of data that are potentially possible with these sensors, okay, yes, this prediction also is going to be very true. And to quantify this data, again, IDC talks about 80 zettabytes of data being generated at the edge. So that's huge amount of data. And then all this has to be securely brought in so that I can process it in a timely manner, because any data that's there at edge comes with an expiry time. It needs to be, some of this information needs to be processed in a very, very short time. Okay, and then that shortest time could be in milliseconds, like some of our earlier presenters spoke about. Or it could be that, okay, the data itself is going to come at a random period, and then it becomes critical that it needs to be processed now. So if I have to weed through a large volume of data, okay, or a stream of data that's there, and prioritize one element, that's what we need to do. Okay, so that becomes the foundation. How the processing of data that's generated at the edge devices, okay, and then also onboarding the devices becomes. Look at what are the sources of devices or sources of data that we may have. I'm envisaging that we are going to have sensors along the track. Okay, these sensors might be looking at the vibration, or it could be air quality, or it could be moisture. Okay, multiple stage, because at this point, what we are looking at is what are the things that I can include in this monitoring perspective and bring those data elements in so that I'm able to process go wrong, so that I avoid an accident or I avoid a situation that happen and that's going to have a larger impact for railways. And if we look back on all the news articles where we are seeing a experienced driver, engine driver, okay, sensing that there's an issue with the track based on the noise insight that we want to bring into the technology that we built, so that the whole system functions in a safe manner. You will have sensors on the trains as well. Okay, these sensors might be looking at, still say noise, though the engines and the way they move is going to be quite noisy, but we should be able to distinguish the normal noise versus. Okay, and the second thing that's there is the heat element, the temperature element, the air quality, and then the moisture. So different elements are there which reside inside a coach, and then you need to be able to use that data coming in. And then interestingly, the processing, we may have to do it within the train itself rather than taking it. And this is where the cloud residing within the coach or within the train, and it's going to create a distributed data center. And then the other aspect in from the visual feeds or video feeds that you may have depressions. Happens when I look at condition monitoring is able to use a combination of all this data in a secure manner, and then be able to manage this, okay, in a timely manner, so that the data that's processed is not lost. Deploy this in all my technology that's essential for this, and manage it combination of decentralized manner as well as centralized manner. Okay, so this slightly complicates the. How do we simplify this? Very first thing that we need to look at is we can learn a lot from what has happened in the past 2 years. There are many IoT projects which have been successful, many IoT projects which have been unsuccessful. And the learnings are there from both of them. Deploy IoT is the number of that we will end up having all these sensors which are connecting to the network in some form or the other, billions and billions, if not thousands in a particular area. It means human management perspective, we are not used to managing so many devices, and we need to actually rethink the way we are going to do this work. Second thing that we have seen is the IoT devices themselves may not have. So how do I bring in the security? I'm able to mitigate any risk that's potentially possible from these IoT devices. The area, able to get a visibility on all the devices which are there on the network, any network, okay, or it might be on the operational side. This device exists, and then this is there now. Visibility, and in your case, okay, it's going to be in a distributed manner, maybe at the divisional office level or the regional office levels, and scale up seamlessly. Next part is security has to be prime, because you don't want somebody hacking these devices, creating a nuisance because it gets compromised. It's capable, there's a potential of it impacting everything else. And this has been the learning that we have had from some of the projects that we have seen in the industry. And ultimately, you have a new category of risk that's going to come in. Deploying these, you may advertently introduce errors because you didn't consider something. The technology itself has got some shortcomings. So you need to look at how do I bring in coverage to address all of this so that I'm now having a vision towards or visibility towards how I can successfully mitigate and make my project successful. Challenges that we have seen is from a POC perspective, it worked fine. Go into production, and then POC had about 10 sensors. Production has 100 sensors issues. And now if I were to scale this up, the other aspect that's there when you look at the IoT sensor is there's a broad range of sensors which are going to be the upset of this over here. And we need to look at what is the right sensor, right technology in the right place. And then some of this might be the reality that you want to use to train a technician or guide a technician through what needs to be done. Be the vibration sensor or rotation sensor, acceleration sensor that might be there in the train. Continuously doing work, everything working are the readings that I'm gathering from the sensors normal. And then is there any spike that's there? Is the spike consistent? Is what we need to be looking for. And then another thing that we saw from one of the other sites, okay, that we were looking, we saw a huge range of failures in projects. And some of the things that attributed was there was no clear-cut guidance between what the business problem was and then what the sensor itself was supposed to do. The aspect that was there is, okay, how do we secure the sensor? I spoke about this. How do we manage the deployment of this sensor? Okay, does it require somebody to physically be there? And then in India, we have other challenges also. If it's something that's going to be there in track, possibility of a monkey or a cow, okay, going and messing around with that. And where should this data be processed? Should it be processed, or it could be in a train station, or it has to be done within a coach, or it has to be done elsewhere? Okay, so, and then the classification of the data generated by the sensor, whether it's normal, wherein it can at a later point of time, or it's critical or hypercritical. Okay, so if I'm seeing a spike in temperature in one of my sensors, then that becomes hypercritical, and then that needs to be taken, okay, to its destination with least network latency, because so many sensors and so many devices generating data that can get architect the elements surrounding this to be successful in delivering this. HPE and Aruba came up with for the intelligent edge, wherein the edge is always connected infrastructure, so that the data can be processed in different places. And then the AI and analytics itself can be autonomous, which means it can be processed in a contained location. It doesn't need to be processed everywhere. It's all secure. Okay, it doesn't matter where you have deployed. It could be that you're deployed a server, an edgeline server within a coach, or it could be in the train. It's sitting in the data center, wireless, wired, okay, and then different types of connections that's going to be there surrounded by services. And adding to this, we brought in a software-defined layer, okay, so that it becomes easy for us to onboard these technology, orchestration, AI, ML, we call it for management, application services aspect, as well as build a very, very powerful security, which is going to be what zero trust security, okay, so that you know that all aspects. So I'm going to cover 3 of these areas in my subsequent slides. Very first thing I want to talk about is how you're going to connect, okay, with technologies that you may want to deploy, coming on Bluetooth. Some of the sensors support Bluetooth, and then you need the proxy coming on net port, cellular or so it doesn't matter what kind of links are there, these devices, these multiple protocols, and simplify the way you're going to work with these sensors. Way to look at it is when I want to plug my phone charger to the wall socket, I'm not going to see whether the wall socket is capable of supporting that or not. If it's a 2 socket, then if it's a 5 amp socket, I plug in the right plug in a 5 amp, 16 amp socket into a 5 amp. So those different standards and different bring in the same thing so that it becomes easy for us to onboard the different tech you plan to deploy and bring them onto the network so that the connectivity sees. With the connectivity, you also need to worry about how you're going to process this data, and where you're going to process this data. We have spent a lot of time on the algorithms. So from acquisition perspective and analysis and acting perspective, do you want to be require aggregation? And then is there any mining that needs to be done? Looking at what is there. So mining is going to be more prevalent in the data centers wherein you have got data from multiple sources, multiple stations. Then you are now looking at, is there a that we want to recognize that's going to lead to a new use case that's being brought in. And then you have use cases that are there. So how are you going to bring in the different use cases that I can process the data in the right place at the right time, used at where it's required? For example, if hot axle, be able to know that right away. So the engineer who is managing the train as well as the guard saying that you have a challenge here with train, and then also alert the station. But when I shift to continuous monitoring, can I look at the trend or condition occurring, by going into preventive maintenance? That's what we want to get to by using the techniques that are there, by accelerating the analysis of the data, in the right place, and then bringing in the right set of and correlating amongst the data. To do all these things, I need a very, very robust security, which means I need to have visibility to every device that's connected. So we have some technologies, which is the ClearPass device insight and then policy manager, so that I can set up my policies in a centralized location. And these policies will get updated for all the devices that get connected. So that if I have and that needs to talk to elements within the train or the edge cloud within the train, that connectivity is established only with domain. So that needs to be a policy that's centralized, that anytime you have a new device getting connected, the same policy is applied for that device as well. And then go into the platform itself so that the platform itself cannot be hacked. This is where the silicon root of trust and then the TPM, so that there's no ransomware kind of attack that can elements that you would be using. And this is going to be true when you're looking at deploying a railways cloud, because it needs to be secure as well. We need to look at end-to-end security. With this, there are few use cases that we can look at bringing in. Cases which become edge-centric, wherein I need to do processing at the edge, and then be able to do a predictive failure analysis before something goes wrong. It has to happen at the edge itself for many of these things. And then in case of railways, I see one is on the passenger side, what needs to happen. Second part is going to be track side, what needs to happen. All these things kept separate so that it becomes easy for us to look at it as individual islands, but at the same time have governance and policy management so that I'm looking at it overall and manage the whole thing. So we have done projects around IoT in different industries. Within India, it's in factories and then some of the other organizations. And then outside of India, we have multiple projects, and then we bring in that expertise, to help in enabling our customers and then in railways. I've been associated with Indian Railways, I would say, since 2008, wherein I've been working with Chris in terms of the freight management as well as systems over there. When I look back, there are a lot of things that we can do together, to bring in the right experiences. And a quick preview of what I've spoken about, a magic quadrant of Gartner, and then from a cybersecurity technologies that we deploy for making sure that and then IDC as well as Forrester and many have given us a lot of accolades and robustness of the technology that we have. With that, I want to thank you for this time. Open Nishant, you need to unmute your mic.
Thank you. Thank you, Mr. Saman. It's